what have they got you into now? Into chapter 2 yet? Logic and reasoning and proofs?
Yes.
Do you have any material from that?
Yes, I do.
Can you send it to me?
Mm-hmm.
Take a picture of it and send it to me. That's probably the easiest way to do it.
Yeah.
This is a difficult chapter to tutor, chapter 2. At least I've always found it to be so in the past. I'm not sure why. I suppose it's because it's so unmathematical. When you're dealing with reasoning and proofs and logic, it's not always about numbers and equations. Don't tend to give you specific problems to solve. So it tends to be a little difficult to tutor. How are you liking it so far? Are you having any problems with it?
Somewhat.
Are you
It's
having any problems?
hard knowing theorems and postulates.
Right. Well, they give you some rather strange algebraic properties of equality. How far into chapter 2 are you?
2.7.
Pretty far in. Yeah, that's pretty much chapter 2. In fact, my book only goes up to 2.6. And then my book goes to chapter 3. Did you send it?
I'm having trouble taking the picture because I suck at taking pictures.
Well,
yeah.
the lighting is the most important thing.
Yes, I know.
So either turn on a light or use your flash on your camera, and then hold your camera about a foot away from the page. And just keep it as still as possible.
I'm only sending pictures to the problems that I need to do.
Yeah, that's fine. You have the email? You know my email address, David?
What?
My email address?
And I've also done some of the problems. I did some of them in Access. So I won't, yes, I do have your email address.
Okay. Yeah, no, that's fine. That's actually better. It's always better if you've done as many of the problems as you can do and save the ones that you have difficulty with for our sessions.
Okay.
Okay, you've sent them?
Nope. I've just taken the pictures. I said I'm very bad at this.
Okay. What kind of cell phone do you use? Is it a Samsung or a Apple?
I'm using LG.
Oh, that's right. You're one of the few people I know that have an LG.
Okay.
Better than a Samsung 7, I guess. Those are the ones that are catching fire and exploding. Not just catching fire, but exploding.
Samsungs are literally exploding.
Right. I've seen pictures on the news where a guy had one in his car charging and it exploded and set his car on fire and destroyed the car too. Haven't quite mastered this lithium technology yet, I don't think.
I'm trying to find a picture.
Well, unfortunately, I don't know how the LG works, so I'm going to have a hard time helping you with that. But usually with my phone, I use a Samsung, and with Apples, when you
Oh,
take a
I
picture,
guess I deleted the
it goes
picture.
into a gallery. So you need to find
I
the
think I deleted the picture.
find the
It's
picture,
not good.
highlight it, and share it.
Okay. By the way, the kid who had this textbook before I did, he wrote a lot of stuff in it.
Oh,
He wrote in the book.
so you get used textbooks.
Yeah.
Sounds like me.
Why
I do.
would he send why would he issue out textbooks that aren't like original that are original, like
That's a good question.
spending what?
I said that's a good question. Do you have to? You apparently don't have to pay for your textbooks at Chatfield.
No, we do not.
Okay. Because
Yeah, I sent it.
clearly, if you did, they would not be giving
I
you
sent it.
textbooks. Send it to David Cowan 1949
Yes.
at gmail.com.
Yes.
How many pictures
I
are
did.
attached?
2.
2. It's not coming
Yes.
through yet. It usually comes through pretty quick.
Maybe refresh the page.
I'm refreshing it every time I hit inbox. It's checking to see if any emails come in. There it comes. It's always interesting that my phone gets it before my computer. I never have quite figured that out. Which one would you like me to open up first? The one on the right or the one on the left? Can you tell?
I'll open the one on the left.
All right, where would you like to start?
At 7. Because I already did questions 1 through 7. I also, yeah.
Okay.
And we're just working a few questions.
Quite get the top of this page, but as much as I can read is the x-axis and y-axis, what? What's the rest of that?
Oh, are perpendicular to each other.
Okay, and the axes form 4 angles.
Oh, yeah, I already answered that.
Okay.
Sorry, I already answered that one.
Okay, where else?
What?
What next? You said there's only specific problems you need to go over. You want to go to 8?
So we need to go 1 through 29, and then question 37, which I did, and then question 42.
All right. So as far
So
as
I've already done 1 through 7 and 37.
So let's do 8.
Yeah.
Hold on a moment. Let me pull this up in a manner that's a little better. There we go. So we have a pair of scissors that really are just 2 lines that cross. And that's angle 1, that's angle 2, that's angle 4, and that's angle 3. Have I got it labeled right?
Yes.
Okay. So they tell you angle 1 is 145 degrees. So
that would have to mean measure of angle 3 is 145 degrees also, due to the vertical angles property.
Good. What about 2 and 4?
And measure of angle 2 would have to be, it would have to be, sorry, it would have to be 35 degrees due to the linear pair postulate or theorem, I forget.
Linear pair is probably all you need to say. I don't think it matters whether you call it a postulate or theorem.
I know, just, but what would it be? Postulate, is it a postulate or a theorem?
I don't honestly know.
I can just check through my notes.
Okay. That's one of those things in geometry that I don't kind of remember because it's not important.
Okay, it's a postulate.
Whether it's called a postulate or a theorem, you'll never have to know again unless you're teaching a geometry class. Okay? The important thing to know is that you recognize a linear pair and that you know that they are supplementary. That's what's important. And that vertical angles, that you recognize those and you know that they are equal. If you know that, that is sufficient, in my opinion. Maybe not to your teacher. He may want you to know whether it's a postulate or a theorem. I couldn't care less.
Yeah, it's a postulate. He'll only want us to know what it is if we're proving.
Okay. In other words, when you're listing the reason, you have to list whether it's a postulate or a theorem. All right.
Yeah. We did our main proofing homework last night.
Okay. Questions
all we had were
questions 9 through 11. Are those going to give you any difficulty at all?
No, not at all.
I didn't think so. So let's not waste time doing stuff that's not going to give you any difficulty. In other words, let's try to focus our stuff on stuff that you're having some difficulties with. I'm not here just to reinforce your knowledge of what you already know. Okay? I mean, I'm fine with doing that, but I don't, in your particular case, I know you know all 4 of these and you're not going to have any problem at all. Remember what I said was one of the greatest skills in geometry was the ability to subtract a number from 180?
Yeah.
Well, you got to do that with all 4 of these angles to find the linear pair.
Yeah, I'm just doing 9, 10, 11 now because I want to get it done and not have to go out of order.
Okay. So number 9, what's angle 1? I'll go through it with you.
Angle 1 is 168 degrees.
Okay. And they don't actually ask you to give any reason, right?
Nope.
Okay. Angle 2 is what?
Measure of angle 2 is 22 degrees. Measure of angle 3 is 168 degrees, and measure of angle 4 is 22 degrees.
Okay, hold on. 168 and 22 adds to what?
What?
How much? 168 and you kept telling me 22.
Oh, no. 12.
Aha. Notice the mistake, and this is a very, very common mistake that I don't want you to make when you get on the test.
90. 190.
Notice that those 2 numbers add to 18. They always need to add to 17, not 18. If I make this 12, those 2 numbers add to 17.
Yep.
Now, when I say always add to 17, unless this number is a 0, then they need to add to 18. But if that number is anything other than a 0, they need to add to 17. So if I gave you this angle right here, what's the supplementary angle to that?
The supplementary angle to that would be 101.
And notice those 2 numbers add to 17. That's always the check. And you always want to be checking. That's one of the secrets of math, is always be checking. In other words, after you gave me that answer, you should, in your head, be adding it back to the number 168 to make sure that it adds the 180. Okay?
Yeah.
If you can develop that habit, it will eliminate a lot of mistakes. How about number 10? What's angle 1?
Measure of, yeah, so it's given that measure of angle 4 is 37 degrees. That would mean the measure of angle 2 would have to be 37 degrees. The measure of angle 1 would have to be 143 degrees, and the measure of angle 3 would have to be congruent or equal to the measure of angle 1.
Again, notice those two numbers add to 17.
Yes.
Okay, how about number 11?
Okay, the measure of angle 2 would equal 62 degrees. The measure of angle 4 is 62. The measure of angle 3 is 118 degrees. Measure of angle 1 is 118 degrees.
Okay, cool. Let's go forth. Number 12. You have to do all of these, right?
Yeah, everything.
Well,
Until 29.
if this is the extent of the writing in your book, so far, not so bad. That doesn't hurt too much. Give me an equation on number 12 that will allow you to solve for x. Let's talk about x only for the moment.
So 8x plus 7 equals 9x minus 4.
Go ahead and solve that for x.
Okay.
Tell me how you're solving it also.
Okay, so first I'm adding the 4 I'm just so used to proof. I'm trying to get used to proofs using the angle, the addition property of equality, I think.
Right. I guess
so I get 8x plus...
Oh, go ahead.
So I get 8x plus 11 equals 9x. Then I subtract 8x from both sides using the subtraction property of equality. And I get x equals 11.
Very good. And then solve for y.
So there are two ways I could do that. I could either use the linear angles property or the vertical angles property. I think I'll use the vertical angles because that just seems a little bit easier.
Well, it is easier because the linear property requires you to remember what x is. In other words, it's true that you did just solve for x. X is 11. And we could substitute it for 11. But that's actually harder, to me, it seems harder than using the vertical angle postulate. So if I'm using the vertical angle postulate, what equation can I write? Geometry is all about
you can just write
to a point where you can write an equation and solve it. Just remember that.
Yeah. Isn't that algebra though?
What's that? That is algebra, but half of geometry is algebra. It's getting...
Algebra is the basis for everything you do.
Yeah.
Math.
No, for sure. I would say that if you were to take a final on your geometry test today, that 75%, 3/4 of the problems would be the type where the solution requires you to write an equation and then solve that equation. So kind of get in a habit of that. This looks like algebra.
We also have a lot of postulates, proving involving postulates, theorems, definitions, and
I understand that.
And properties that I don't know.
I understand that. And you'll just have to memorize those, and we'll get to those when we get to those. Okay? It's kind of like when you subtract or added 4 to both sides on the previous page, you were using the addition property of algebra.
Yeah.
Okay? Well, the most important property of algebra that you can know is that you can do anything to one side of the equation as long as you do it to the other. So I'm a little annoyed that they force you to learn an addition postulate and a subtraction postulate, because the truth is that when I say anything, I mean anything. There are about 100 different mathematical things you can do to one side of an equation as long as you do it to the other. So the most important thing for you to really understand is that. Whether you know the
So,
exact postulate or not, to me is relatively unimportant. I understand that certainly in chapter 2 you're going to need to know it, but trust me, it's going to go away pretty quick. Once you get through chapter 2 and you get on to the rest of geometry, you don't really have to deal with that. I'm not going to call it nonsense, but I don't care for the way they teach it. What equation can I write for number 12 that lets me solve for y? Verbalize it for me.
you can write 5y equals 7y minus 34. Now, I could solve that right there without like solving the equation.
Good. Well, you'd have to solve the equation. So tell me how you would do that.
No, so I noticed I can do right now, like, see that the difference between 5y and 7y is 2y.
But
And
that's using the subtraction postulate.
no, but also I can, without like writing out and solving the equation. But
Right.
I can also see that
what you're doing here is you're going to subtract 5y from both sides, right?
yeah.
Leave 2y over there. It's going to leave 0 there, and you still got that 34. And now you're going to add 34 to both sides to get this. Yeah. And then you're going to divide
34
by 2.
Well, I can do that in my head, like super quick.
That's all you need to be able to do, Bolton. Don't get confused about what they're teaching and what's important to understand. Okay? What's important to understand is that you can do anything you want to one side of an equation as long as you do it to another. But the fact of the matter is that if that's step 1, to get to step 2, I had to subtract 5y from both sides. So I had to use the subtraction property. To get to step 3, I had to add 34 to both sides. I had to use the addition property. To get to step 4, I had to divide both sides by 2, so I used the division property. Okay? So that's what all technical names are, but the fact is that I really didn't need to know those names.
Yeah.
Okay.
I'd like to do 42. I'd like to do 42 now just to ensure that we have enough time for it.
Okay, hold on a second. Let me find it. Is it on this page?
It's on the next picture I sent you.
Okay.
I sent you a picture of only...
I see it. Okay.
What?
2-column proofs.
Yeah. I know about 2-column proofs.
Okay, good.
Those aren't hard. It's just...
Okay. So
like using the...
Here's what we want to set it up. So we have, let's start with the given. What's the given?
I'm actually like writing
angle
statements
1 equals angle 3. And we're to prove that angle 2 equals angle 4. So the way I like to do these 2-column proofs is down here at the bottom, I'm going to come up with angle 2 equals angle 4. And I got to somehow get there.
Yeah.
Well, what's the second statement going to be? If angle 1 equals 3.
Angle 1 is equal to angle 2.
Correct. Why?
Vertical angles property.
And that's all I have to write. Vertical angle property. Now, what's the third statement?
Give me a minute. The third statement is that angle 3 is congruent to angle 4.
Good. Angle 3 is congruent. We'll go ahead and use the congruent sign there.
Yeah. I'm using congruent sign always.
And that's vertical property.
Because I don't want to write it the long way and say the measure of.
Yeah, no, it's confusing to some people, the difference between congruent and equal, but
it's not confusing. It's just a matter of whether I actually want to write it out.
Okay. All right. We'll leave that discussion for a later day as to what I consider the difference between equal and congruent. Congruent's fine. They want you to use the word congruent for sure. And
so what we can do now is, oh, sorry.
No, what's the next line?
Well, substitution. We need to do substitution.
Okay.
So things like measure of angle 1 is equal to the measure of angle 3.
Well, that was a given.
Yes.
And,
oh, yeah, no, sorry.
And the measure
now we
of 1
is substitute
that. To 2.
The measure of angle 2.
Figure that out. So the very fourth statement is the bottom one. In other words,
yeah, wouldn't this be
it's now
would this be the transitive? Would this be the transitive property or the
substitution?
Okay.
Yeah. Hold on a second.
Because the substitution property says if angle 1 is congruent to angle 2 and angle 2 is congruent to angle 3, then angle 1 must be congruent to angle 3.
That's the congruent supplements theorem. No, it isn't. It's the substitution.
It's also the transitive
equality is what it is. The substitution property of equality.
Yeah, but it could also be taken as the transitive property of equality. But
well,
I don't think it matters much.
You're right. It doesn't matter much what it's called. And I guarantee you will never, ever be tested on that once you get through this chapter and maybe the final at the end of the semester. Okay? What's important isn't the right side of this proof. What's important is the left side. In other words, the fact that you knew angle 1 was congruent to angle 2 and that 3 was congruent to angle 4, and that then you recognize that since 1 was congruent to 3, 2 must be congruent to 4 because of the substitution property. Substitution property basically says if A equals B, and
so like we learn that if we learn that angle 2 must be congruent to angle 3, and that would, and since angle 3 is congruent to angle 4, that would also have to mean that, using the transitive property.
Here was the logic we went through. Just a second. And I'm going to shorten it up a little bit. Here was the given.
Am I getting it better than some other kids?
1 is congruent to, 2. That's what was the given. Here's what we know from our theorems. 1 was congruent to 3. Here's what we know from our theorems. 1 is also congruent to 2. Well, by substitution, that makes 1 congruent to 3. Okay.
But also because of the transitive property.
Right. Okay.
I don't know why I'm bringing that in.
Well, then you can say that 3 is equal to 4 or congruent to 4 because of vertical angles, which makes 2 congruent to 4 because, right, because of the substitution property.
Yeah, I'm just stating both. But yeah, I think that's it. We only need to do 42, and that.
Get one that uses the transitive. Let me read the transitive property. If A is equal to B and B is equal to C, then A is equal to C.
Then A is equal to C.
Right. Well, is that what we did here? Not really. We said 1 was equal to 3 was given. And then the next step we said was that 1 was equal to 2 because vertical angle. And the next step we said was that 3 was congruent to 4 because of vertical angle. And that means that if 1 is congruent to 3 and 3 is congruent to 4, then 1 is congruent to 4 by transitive property. And since 1 is congruent to 2, then 2 is congruent to 4 by substitution. I think that's probably how it should go. There maybe should be 5 steps. And I think first time I did it, I only did 4 steps. And there actually are 2 steps. One uses the transitive, one uses the substitution. And I hate to call them proofs because you want to demoralize a geometry student, just give them a bunch of problems like this. It's a horrible way to start out geometry, in my opinion. I much prefer starting out geometry learning about angles, lines, triangles, circles, quadrilaterals, things like that. And parallel lines. Parallel lines are very, very important. And
except the thing that no one has stated, Mr. Yansak still hasn't stated the postulate or the theorem. Would that be a theorem that that all angles of a triangle add up to 180?
You haven't got there yet.
Yet.
That's
which is surprising because that's very simple and easy.
Right, but yeah, they when they deal with this chapter 2 on proofs and theorems and stuff, they really are dealing more with logic. And I don't know what else. Like I said, I've always had difficulties tutoring it. I suppose because, I don't know why, to be honest, but we did 42 and I think we did it properly. And I think these 5 steps are the ones you want. 1 through 5. Okay. Where do you want to go next?
Okay, we'll just go back to 13.
Okay. Tell me the equation that you're going to get from 13. Solve for x. We'll take one variable at a time. Notice one thing first. I could write the following equation, correct? Is that a correct equation? That's a linear pair, right?
Yeah.
Okay, so that's a correct equation. Linear pairs are supplementary. They add to 180. The problem is that does not allow me to solve for x or y because I have one equation and 2 variables.
Yeah.
So that equation is not particularly helpful.
You have to eliminate variables.
Well, you have to kind of solve for them one at a time in some cases.
Yeah, and plug things in to find out.
Yeah, although in these problems, you don't even have to do that. What's one equation to solve for x?
4x equals 6x minus 26.
That's one.
And the answer that would herald would be x equals 13. Yay.
So that's one equation and one variable. Now, we could plug in 13 for x and go back to the equation I just wrote, but even that isn't necessary. How do you really, what's the easiest way to solve for y?
Just plug things in and do add up to 180.
An equation that lets me solve for y in one step. Same way you just solved for x. Look at the vertical angles.
Yeah. So
Equals what?
oh yeah, that makes sense. Okay. So since x equals 13, that would have to
No,
mean
hold on.
4.
There's two ways to do the rest of this problem. The first way to solve for x we did. But now to solve for y, there's two ways to do it. I could plug in x and I could say this upper right angle and the lower right angle at the 180, and I could substitute 13 for x and I could solve for y, but I don't think that's the easiest way to do it. There's an easier way. What's true about this 7y minus 12 and the 6y plus 8?
What?
What is true about the angle 7y minus 12 and the angle 6y plus 8?
That they're equal?
Yeah. And that's the easiest way to solve for y. It isn't plugging in for x. Okay.
Yeah, I never said it was. Using vertical angles is always.
This solves in one step. Okay. So I have very little arithmetic that I have to do if I do this to solve for y instead of plugging in x. Now, there are going to be some geometry problems where you have to solve for x and then you have to take that answer and plug it in and go forth like that. So I'm not saying you would never have to do that, but always solve these things in the easiest way possible.
Yeah.
So, and let's just set the equations up. I know you know how to solve these equations. So just on 14, give me the equation to solve for x.
Okay. X 10x minus 4 equals 6x plus 12.
Okay, good. I know you know how to solve that. How would I solve for y?
Okay. How do you solve for y? 18y minus 18 equals 16y.
Simple as that. And then
Meaning
the answer for x and y, you're going to get by solving a very, very simple algebraic equation. Okay?
Yeah.
Let's go on to 15.
Sometimes I don't even need to solve. I can just use common sense.
Well, you're not really using common sense. You're really solving an equation. You're just doing it in your head. You're doing 3 steps in one. Okay? But if you break it down, you're always solving an equation, and you're really doing it by doing the same thing to the left side of the equation as you do to the right side. And you might do 1 or 2 steps all together, but that doesn't matter. Let's look at 15. Describe the error in stating that 1 is congruent to 4 and 2 is congruent to 3.
Give me a minute. I'm trying to finish this answer for 14.
Okay.
I
think we had x equal 13 and y equal 20.
Okay. For what? Oh, no, I'm doing 14.
We just did 14. Ah,
Yeah,
oh,
yeah,
I have written up here was 13. Yeah. Okay. You got 14 done?
yeah.
Okay. See, I don't care about the answers because I know you know how to do that. What I want to work on is the stuff you're not positive you know how to do.
Okay.
Like 15.
The error,
What's the error
the
there?
error in stating that those are not straight angles.
They're not straight lines. And unless
Yes,
they're straight lines, then 1 is not vertical to 4. And 2 is
yes,
not vertical to 3. So there's no proof whatsoever that 1 is congruent to 4 and 2 is congruent to 3. They would be if they were straight lines, but without those being straight lines, you cannot make those statements.
yeah.
Okay? Let's look at 16. In a figure,
Angle A and angle D are complementary angles. The measure of angle A equals 4x. What expression can be used to find measure of angle D? So it's going to be answer D, 90 minus 4x.
so
That's so obvious.
okay, but still let's write it out as algebra. In other words, I don't
Yeah.
want you to get away from the algebraic solution to these problems. Okay, even if you can do them in your head. So what I'm going to say is angle A plus angle D. They're complementary means what?
They equal 90 degrees.
Okay. And then I know that angle A is equal to 4x.
4x.
So I can
So
substitute 4x plus angle D equals 90.
degrees.
And,
And then use subtraction
right?
property of equality. So minus 4x.
That's how you got the answer.
So angle D equals 90 degrees minus 4x.
Correct. Correct.
Degrees.
All right. Let's look at 17.
Okay. In exercises 17 through 21, copy and complete the statement given that the measure of angle FHE equals the measure of BHG. Those are congruent, and yeah.
All right. Let me look at this for a minute. FHE. Boy, they don't put a number on that. It'd be so much easier if they numbered it. BHG is which number? That's not a number either. That's one.
There are no numbers for it because there's a ray coming out of it.
Okay. All right. So all of those three angles are equal and they're all 90 degrees.
Yeah. So if measure of
they want to know what angle 6 is.
okay, but using the vertical property, we can easily tell that angle 6 is 30 degrees.
Perfect. Assuming you know that GD is a straight line.
Yeah.
I'm not sure.
And we do know that.
How do you know that? Ah, because BHG
because there's a midpoint 8.
and B.
Oh. Okay.
Yeah.
What?
Well, I'm still not sure you know that's a straight line by the information they've given us. FHE is that lower right quadrant. That's 90 degrees. We know that. BHG is the right angle that's kind of tilted, making up angles 1 and 7. So we know that's a straight line, or we know that's 90 degrees. And then AHF, that's 90, which makes AHE a straight line because we're given two 90-degree angles. Okay, so we know that AHE is a straight line. I'm not sure at the moment we can prove that GD is a straight line. Nonetheless, copy and complete the statement given. So is all you need is an answer, right? You don't need a reason.
Yeah. But what we can assume is that line DG, they are opposite rays of ray HD and ray HG.
How do you know they are? In other words, it certainly looks like a straight line, but could that one angle 3 be 1 degree different and we wouldn't be able to recognize whether it was a straight line or not?
No, we wouldn't be able to recognize that.
I'm not sure. Yeah, I don't personally see the proof of it, and I have a feeling it has to do with a little more complicated proof, but let's go through each of these and maybe we'll figure out something. So I agree with you that angle 6 is most likely 30 degrees, particularly at this stage of geometry. They're not going to throw that non-straight line in at you. And maybe the fact that there's an arrow on that end and an arrow on that end does mean that GD is a straight line. That ray is a ray. So perhaps we can assume that that's a straight line because of the arrows on both ends of it. Okay?
That's what I was saying.
Yeah, okay. Let's look at 18. If BHF is 115, then what's angle 3?
Okay. So that would mean angle 6 is, because BHG is 90 degrees, that, and 6, it just makes up that 115 degree angle.
Right.
Then angle 6 would have to be 25 degrees, and we're assuming that line GD is straight. So angle 3 would have, measure of angle 3 would have to be 25 degrees.
Correct. Okay. How about 19?
Okay. Let me write this down. Okay, never mind. 19, if measure of angle 6 equals 27 degrees, then the measure of angle 1. Okay.
It's a little more complicated, this one.
How would I prove that, though?
Okay. If 6 is 27, what is...
I know how.
Okay.
I know how. Okay. So that would have to mean that angle 3 is also 27 degrees, and since 3 and 4 are complements, then 4 would have to be 63 degrees, and since 4 and 7 are vertical, 7 would have to be 63 degrees, and because 7 and 1 are complements, then angle 1 would have to be, it'd have to be 27 degrees, right?
Well, let's see. You said 3 was 27, making 4 not 73, but 63. Again, when you're subtracting numbers from 90...
No, I said 63.
Ah, you did. Okay. Again, those two numbers need to add to 8.
Yeah.
Okay. So 63 is 4.
And then,
So 7 is 63. And we know that's 90. So 1 is 27. Okay.
yeah. I said 63. Sorry if you didn't, if it wasn't discernible.
I heard you incorrectly. I apologize. Okay. And number
Okay.
20, DHF.
Wait, so I'm correct, right?
Yes.
Okay.
So DHF is 133. And they want CHG. Which one is CHG? Okay. G.
C, where's C, H, G? That would also have to be, 100, and 33 degrees because those are vertical angles.
They're not.
They intersect at a midpoint.
Well, they are, aren't they? I didn't even see that.
Yeah.
They are vertical angles. DHF and CHG are vertical angles. Very good. One step. Yeah. Okay, how about 21?
If the measure of angle 3 equals 32 degrees, and the measure of angle 2 is how many degrees? Okay. So we can assume that we're still assuming that GD is
Yes.
a line and it's
Yes.
180 degrees.
GD is not a straight
So
line.
that would
do any of these problems. So we kind of have to.
and because
GD is
and because BHG is 90 degrees, we would also have to assume that BHD is also 90 degrees.
correct.
So if the measure of angle 3 is 32 degrees, we can confer that angle 2 is its supplement, meaning angle 2, 32 degrees, meaning angle 2 would have to be 58.
Right. It's its complement, not its supplement. Supplement means they have 80.
I get those mixed up, but
90. Yeah. Okay.
I get those mixed up sometimes, but I don't actually like.
Well, no, you understand it just fine. Yeah. And getting the terminology is, it's critical for your geometry class, but that's about it. You won't ever do geometry problems where you'll have to know the terminology. It's not part of geometry once you get out of geometry class. I mean, I know that sounds terrible, but that's the truth of the matter. So I'm not saying terminology isn't important. Certainly you want to know what the difference between supplementary and complementary is, but some of the terminology is just not that important. All right, analyzing state.
I'm going to make a little diagram.
Actually, it's almost 5 o'clock here, so why don't we stop there at 21, unless you have a...
Can we do one more problem?
Yeah, if you want to pick one that...
Can we do... No, can we... I think we can do the entire set, like 22 through 27 in like 2 minutes.
Okay. So we got two lines that are
or I'll just do
not perpendicular to one another, like that. Okay? They intersect.
Then the measure of angle 1.
And 1 and 2 is a linear pair.
Because they're not perpendicular, then.
And 1 and 4 is a linear.
Okay, no. Because angles 1, yes. Because angles 1 and 2 are a linear pair, but the lines are not perpendicular, meaning no right angles are happening. There are no right angles. Then angle 1 cannot be congruent to angle 2, so that it's false.
Okay. How about 23?
Angle 1, So yes, angle 1 and angle 3 are congruent because they are vertical angles,
About
and that is
24.
given. 23.
No, you're correct.
So
How about 24?
that is false because same thing with 2.
Correct. As long as we know that angle 1 is not 90 degrees, then we know that angle 1 cannot be equal to angle 4.
And since we can also see that angles 3 and 2 are a linear pair,
Right.
then they can also not be congruent.
Okay.
Angles 2 and 4 are vertical angles, so they must be congruent.
Okay. And what's 27?
And
What's 27 say?
the measure
3 plus angle.
and the measure of angle. Okay, the measure of angle 23 plus the measure of angle 3 plus the measure of angle 4 equals 180. Angle 3 and angle 4 are a linear pair, so that must be true.
Okay, cool. You're right. We were able to do all 6 of those in 2 minutes. All right, Bolton.
These were very simple.
Yeah. Okay, well, you'll probably still be on, well, maybe not. You might be on chapter 3 by next week, but you are.
Oh, yeah, we will be on chapter 3.
Yeah,
because
we almost finished chapter 2 now.
it's Tuesday, right? We're like 1 day behind the geometry class because I think we spent we spent a day doing something else and not actually in the textbook.
Okay.
Just spend or something. I don't know what.
You spend a day on calculator?
No, we didn't.
Oh, because I got a lot.
So we're behind them, and today their homework was the chapter 2 review packet.
Okay, cool.
So they must be having a test soon, and when we're done with chapter 2 review packet, we're on to chapter 3, even if we're still not done with the test.
Okay. All right. Bolton, I will talk to you next Tuesday at 4.
Okay. I will talk to you too.
Okay. Bye-bye. Have a good week.